Hello students, how are you? Today we discuss the trigonometric functions part 1. In the trigonometric part 1, we already discussed angles and measurements. What is angle? And we also observe that this is your angle APB. It's a combination of two rays. And we represent this angle is APB or in different forms. Now these three important kinds of triangle, acute triangle or your obtuse angle and right angle triangle. So these three types of angles are also used in the formation of triangles. In the triangles formation, that triangles form is one is your acute triangle. Acute triangle means all the angles are less than 90 degree. And second one is obtuse triangle. That is represented like this. One angle is more than 90 degree. And third one is right angle triangle. And this right angle triangle is represented by like this. So this right angle triangle is a very important triangle, and the whole branch of mathematics is based on this right angle triangle. The branch of mathematics based on right angle triangle. This right angle triangle, all the three sides are represented by three different names. One is your perpendicular. This is hypotenuse. The length of hypotenuse is, and the BC is my base. So the important angles of the triangle is the ratios of these three sides. The first angle is sine theta. This theta, or you can say alpha, beta, gamma, or write your name even, there is no problem. That's the representation of the angle opposite to your right angle triangle. This is we can represent or from like this. So this is equal to sine theta is equal to perpendicular, hypotenuse and base, and therefore it is written P upon H is equal to AB upon AC. And another is cos theta is base upon hypotenuse, that is equal to BC upon AC. These are our pattern angles. Pattern angles means all the trigonometry other angles are based on these two angles. So this, and therefore one another angle is tangent. In short, we can write here tan theta is equal to sine theta upon cos theta is represented as perpendicular upon base, means AP upon BC. Cot theta is 1 upon tan theta, means cos theta upon sine theta is equal to BC upon AP. Or we can say that this is equal to base upon perpendicular. Cosec theta, this cosec theta is equal to 1 upon sine theta, and that is equal to hypotenuse upon perpendicular, and that is equal to AC upon AP. And similarly for the sec theta, that is 1 upon cos theta, and that is equal to hypotenuse upon base, and therefore it is represented as AC upon BC. So all these four angles are based on this sine theta and cos theta. Here, there are two types of angles in this our coordinate system, coordinate geometry system. Suppose this OP is my line, and this type of angle with the direction of this arrow is anti-clockwise. When it is the anti-clockwise direction, then it's a positive angle. And I am not just any theoretical method or anything. I just want to clockwise and anti-clockwise direction. This is clockwise direction because we know that the clock is moving from this direction to this direction. Suppose this is my clock, and in this clock the direction is, yes, in this direction of the hands of that clock, and that is called your clockwise direction, and in the opposite is called your anti-clockwise direction. So that's why it's a clockwise direction and anti-clockwise direction. I want to show that this trigonometric function is actually a circular function. This circular function is divided in four parts. One part is I am taken as your first quadrant. This is my second quadrant. This is my third quadrant, and it's my fourth quadrant. We use these quadrants after some time in the next videos. In this first quadrant, the coordinates of any point P on AB arc is AB. The meaning of AB by our knowledge of coordinate geometry, that if we draw a perpendicular PM on OA, then that is equal to your A and that is equal to B. So naturally, in this triangle, in a right angle triangle, OPM is equal to, by Pythagoras theorem, this Pythagoras theorem is OP square is equal to PM square and plus OM square. Here, mention the one important point, the radius is 1, means it's a unit circle. So, here radius of circle is 1, or we can say it's a unit, and therefore unit circle, and that is equal to 1 square, and that is equal to PM. PM square means straightforward, it is your P square, and OM square is equal to A square. If I am dividing by 1 on both sides, then that is equal to upon 1. By our previous knowledge, we have to take in that sine theta is equal to perpendicular upon hypotenuse, means B upon 1 is sine theta, and cos theta is equal to base upon hypotenuse is equal to A upon 1. So this can be represented as sine square theta plus cos square theta is equal to 1. This is my first expression of our trigonometry. The basic, we can say sine square theta plus cos square theta is equal to 1. Now we again, sine square theta plus cos square theta is equal to 1. Dividing both sides by sine square theta, so sine square theta upon sine square theta, cos square theta upon sine square theta, and 1 upon sine square theta. This sine square theta upon sine square theta is 1, and cos square theta upon sine square theta is equal to cot square theta, and 1 upon sine square theta is equal to cosine square theta. This is one more important identity. Now again we are taking sine square theta plus cos square theta is equal to 1. In the previous case we divide by sine square theta. Now here divides by cos square theta, and that is sine square theta upon cos square theta plus cos square theta upon cos square theta is equal to 1 upon cos square theta. So this is tan square theta plus 1 is equal to sec square theta. This is the third important identity of this trigonometry. Here in the example, if cos x is equal to minus 1 by 2, then x lies in the third quadrant. Find the values of the other 5 trigonometric functions. Here, this circular function, these quadrants 1, 2. This third function is sine and cos, both are negative. In fourth function, sine is negative and cos is positive. And first function, sine and cos both are positive, and in the second, sine positive and cos negative. Naturally, the given at cos x is equal to minus 1 by 2. In the third quadrant means sine and cos both are negative. I find the value of this identity sine square x plus cos square x is equal to, I just find out root 3 by 2. Now, other find the values because the sine x is in my third quadrant, so naturally means the angle is in third quadrant. So sine x is equal to minus root 3 by 2. Similarly, this tan x is equal to root 3 by 1 because sine and cos both are negative. That's you should be remember this one. It's careful. Now in cot x is equal to upon 1 by root 3 because sine and cos both are negative. And in the cosec x is minus 1 by sine x is minus 2 by root 3. And sec x is equal to minus 1 upon x minus 2 upon 1. Now this is the finish of the question, and now we come on the different angles in the next video.